All right, so as I mentioned, this section, chapter 8, is on scatter diagrams and correlation. These set of notes were pulling from my statistics course. So that class was 4.1, so that's why I scratched this out. But yeah, so we'll be all right just using these notes. So your scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point, and those points are graphed according to your explanatory variable and your response variable. And we'll talk about the difference in those in a second. All right. All right, is that okay? So, explanatory variable explains the value of the response variable. Is your x variable, it's your domain, input, independent, and horizontal axis. Your response variable is explained by your explanatory variable, and it's also your y-axis, range, output, dependent, and your vertical axis. And so, like I said, I'll show you an example of the difference between the two. Let me get a little further down. But in comparison, that's the difference. All right. And here I just did a general example. No real rhyme or reason as to why those points are where they are. I just want to show you how a scatter plot would look using the positive x-axis and the positive y-axis. Down here you have your response variable, your explanatory variable, excuse me, and your response variable on your vertical axis. So normally you will have numbers that will tell you, where to plot your points. I was just showing you how one could look. All right. Linear relations, when a line best sums up the shape of the scatter plot, and I believe we did this in one of our last homeworks when we had these points, and we were looking at a line that would best sum it up, and we would draw a line through those dots. So if a line best sums up the scatter plot, then it's considered having a linear relation or linear relationship. So we see in the first two, they would be considered linear. The second two would be considered nonlinear. And then that last one is no relation at all. So the fact that it's not linear does not mean it does not have a relation, basically a pattern to it. You see in this first one, not this first one, the third one, there's an arc. And then in that fourth one, there's more like a wave. So there is a pattern going on, it's just not linear. The linear needs to be a line. And in purple, that's what I was saying earlier. Nonlinear does not mean no relation, just means no linear relation. All right, I'm good to scroll up. All right. So associations. If something is positively associated, that means that when one value increases, the other increases. So if you read it from left to right, it goes up. You're always following your points from left to right. From left to right, if it's going up, then that means it's positively associated. But it's negatively associated when one value increases and the other decreases. So going from left to right, if it's going down, that means it's negatively associated. All right. Linear correlation coefficient is a measure of strength and direction of the linear relation between the two quantitative variables. Greek letter rho, I know it looks like a P, but that's Greek letter rho, is the population correlation coefficient, and R is just sample correlation coefficient. R is used most of the time as far as explaining the correlation coefficient.
Professor Tucker.
Yes.
What does that say after the P?
RHO, talking about that?
Yes.
That's rho. RHO is rho, Greek letter rho. All right. All right, can we scroll up? Scroll up. All right, don't need that blue. Here we get to properties of the correlation coefficient. It is between -1 and 1 inclusive. If R is equal to +1, then a perfect positive linear relation exists. If R is equal to -1, then a perfect negative linear relation exists. The closer R is to +1, the stronger the evidence of a positive association. I'll pause right there. All right, number 5. The closer R is to -1, the stronger the evidence of a negative association. 6. If R is close to 0, then little to no evidence exists of a linear relation. And then that goes back to what's in red, goes back to what we were saying before. R being close to 0 does not imply no relation, just no linear relation. So being close to 0 does not mean there is no pattern. It's just not a linear pattern. All right, number 7 and 8 probably won't come up, but um, it is a unitless measure of association and it is not resistant. So that means it is affected by outliers. Like I said, those two things may not come into play when you guys are doing your homework, but it's part of the properties. So it should be fine. Mhm. All right, next few is just examples, rough sketches of how how it looks when r is equal to 1 and how it would deviate from that, moving closer to 0, and vice versa when we talk about r being equal to -1. R equal the positive 1 would be a straight line increasing. Then as it starts to spread out, it goes to 0.9, then maybe 0.4. And then, the closer it gets to 0, the less and less it looks like that straight line. Same thing happens for -1. Then that sixth diagram, you have that arc. Then in that case, R will be close to 0. And okay. And then the last one's doing the same thing. Another example of being close to 0. All right. Last one has close to 0 as well. No relation at all, and no linear relation will both be close to 0. All right, scrolling up, you guys don't need that one. Okay, here, I don't necessarily have to copy this, but I just want to explain the difference between explanatory variable and response variable. Here, we have, we were determining the linear relation between the club head speed and the distance. So we have a guy that's swinging his golf club, and the club head speed is how fast he's swinging, or how hard he's swinging the golf club will dictate how fast the club head moves. And then the distance the ball travels. So your explanatory variable would be how fast the golf club head is moving, and then how far the ball travels is your response variable. It responds to how fast the club head is moving, and then how hard you do it. Would it actually explain how far the ball's traveled? So that's the difference between explanatory and response variable. One explains the other one, and the other one responds to what's happening in the explanatory variable. All right, like I said, you don't need that example. All right, so let's go to the next thing. So the coefficient of determination, this is mentioned as well. It measures the proportion of total variation in the response variable that is explained by the regression line. That next statement basically tells how reliable the regression line is. All right. Is the correlation coefficient squared? I think That's it. For that. So after that, I'll scroll down a little further. All right, let's see. I was going to take note. I think that was it as far as those notes are concerned. Okay, so let's look at this one. And this one may be worth copying, especially when we get to the explanation. So determine and interpret the coefficient of determination of the clubhead speed versus the distance. So we had already found your correlation coefficient, which is R. R is 0.939. You guys aren't going to be asked to actually find that. So it should be already given. So once you have your correlation coefficient, you'll square it. And we ended up getting 0.882. And your coefficient of determination can be expressed as a percentage, which is 88.2%. Just move your decimal 2 places to the right. All right, so the interpretation of that, means 88.2% of the variation in the distance is explained by the regression line. So when we talk about regression line, we're talking about the linear relationship. So 88% of the pattern that's established will continue on as far as what we've done. And then if you subtract that 88.2% from 100, 11.8% will be explained by other things occurring. So if it doesn't fall into the pattern, there's an 88% chance that it will. But if it doesn't, then there's and that 11% other things would be a factor. Let's say the wind blows, the wind is blowing. That can, determine your ball maybe not traveling the distance that it normally would travel. Maybe you don't hit it in the same fashion. Maybe you do some type of glitch that you normally wouldn't swing. So as long as everything stays normal, it should fall into the same pattern. And there's an 88% chance that it will. But like I said, 11% chance that it may not, and that will be explained by other factors. So that's how you use your coefficient of determination. All right. Questions? Any questions? All right. So that is pretty much it. Yep. As far as notes that would be beneficial for you to do sections 8.1 and 8.3. Once again, those sections are definition based. You have to do your scatter plot and all the good stuff like that. So when you look at your scatter plot, if you graph the first 2 points, then that should fall in line with your graphs. They're not many of them that's going to be so close. They're not that close. So once you figure out what the first 2 points are, as far as on your scatter plot, you pretty much will know which is the correct one to choose. But yeah, so check those out. Like I said, I would rather you go in there, read, and say, okay, this doesn't make sense versus me just giving you the answers to those. Just like some of them are answers in there. Like one of them said, if you have a perfect negative relation, what would R be equal to? And so, I gave that to you already. So it's certain things like that. So check it out, see if you have any questions. And don't forget from this point forward, that's what we will be doing. Entertaining questions. I will not bring any new material to the table. I will just come here to ask questions or answer questions. I say not ask questions. So if you decide not to show up, you wouldn't miss anything but questions being answered. Just make sure that if you miss class or decide not to come to class until the final exam day, um, that you pay attention to your emails because I will be communicating through that. Any decisions that or any announcements that I make to the class, I will shoot it out in email as well. Just like the final exam will probably be the week of December 7th through the 9th, either 7th or 9th. So either be on either one of those days, haven't decided which day. But then that next week will be the final week that you can submit your assignments. So do our final test. And remember, your final test will be from chapter 4 to chapter 8. Do your final test that week, and then we have until the 18th, 16th or 18th to turn in final work. So I'll iron out all of the details, but that's what we're looking to do. Do your final test that week of the 7th, and then final submissions will be that following week. And then I'll have to get your grades in. So, and we talk about of December. So, yep. So that's what we're looking to do. Once again, I'm going to solidify what dates, actual dates we're going to do that on. And then from there, move forward. Questions on anything.
I have a question.
Yep.
For the final exam, we're gonna have like a review like we did last time,
You said, are we, or you say you don't want one?
Oh, no, I'm saying, are we going to? No, I like the review because it'll help.
No, I was just messing with you. I just had to create it. Yep.
Okay.
Once I create it, I'll post it.
Okay, thank you.
Yep, no problem. All right. Anything else? Anybody else? All right. So if anything comes up, feel free to email me. I'll email you back and all the good stuff like that. And like I said, from this point forward, I will be answering questions. Oh, yeah. Also, 15 minutes, just like, any other time, you guys give me 15 to show up. I give y'all 15 to show up. Don't no one show up in 15 minutes, then I'm guessing that everybody's good for the day. So just throwing it out there. If you don't come, I understand. You just let me know you don't have any questions. So it's not mandatory that you show. But like I said, just pay attention to your emails as we progress forward. Outside of that, you guys have a great day, and I will see you on next class.